fascination with space and astronomy remains timeless. Back in the days, outer space was an unreachable concept for human beings. But now, all thanks to various different types of space telescopes that have been created with time, all that has become possible to view and analyze. These little devices make it possible for humans to observe and study different kinds of astronomical objects that are far off in space. And out of all these telescopes, the two noteworthy ones are none other than the Hubble Telescope, released back in April of 1990, and the James Webb Telescope, that has just been announced quite recently. And today our video will revolve around these two telescopes. Which telescope is better? What are the features, the improvements, the flaws? And for that, we'll be comparing a few images of different objects. All will be discussed in this video, so stay tuned until the end. First of all, we have a view of the Trifid Nebula in infrared light. The left picture was taken by the Hubble Telescope, and the right one by the James Webb Telescope. The stars behind the nebula are a lot more apparent in the one taken by the James Webb Telescope, including two newly discovered Cepheid variable stars. That means the James Webb Telescope made the details a lot clearer. The exposure and the contrast of the images a lot better, which makes the colors and details so much clearer in the second image. That's why the James Webb Telescope has enabled scientists to discover many new objects in outer space. Next, we have a comparison of the galaxy group Cosmos GR30, which also becomes a lot clearer with the James Webb Telescope, measuring more than 300,000 light years across. Also, because of its powerful eye, astronomers understood that the large pocket of gas is not pristine, but was expelled from galaxies during violent interactions or superwinds. That's because the pixel density and the depth of the image got a lot better with the James Webb Space Telescope. That also made the detailing of images so much better, enabling scientists to make new discoveries. Now we have two images of NGC 4303, a spiral galaxy that has a bar of stars and gas at its center, located almost 55 million light years away from planet Earth in the constellation Virgo. The picture on the left was taken by the Hubble Telescope. In the image, the golden glows show clouds of ionized hydrogen, oxygen, and sulfur gas, which marks the presence of newly born stars. And the regions in blue in the background show the distribution of many young stars. On the right side is an image taken by the James Webb Telescope, which revealed cold cloud of molecular gas, stellar nurseries where new stars are born. Together, astronomers can use the two pictures to examine the region of star formation to understand what triggers or boosts star formation, or what stops the birth of new suns. Well, even in this case, the right picture shows more detail and has a higher pixel density. But let's be honest, both pictures together meant a great deal for scientists. Next up, let's compare two views of the galactic center. Again, the picture on the left was taken previously by the Hubble Telescope, and the picture on the right by the James Webb Telescope. We can see that the sharpness and contrast of the picture on the right is a lot higher, due to which the rings can be seen in a higher resolution, unlike the left picture taken by the Hubble Telescope. Now, let's compare two images of the central regions of the Milky Way, captured at different wavelengths, left one by the Hubble Telescope and right by the James Webb Telescope. The image taken by the Hubble Telescope captured more color, but the one taken by the James Webb Telescope captured more features. The area that shows up as dark dust in this image looks a lot brighter in the previous image. However, we can't directly compare these two images, considering the significance of color is different for both of the images. Next up, we have these two images of the region around Messier 78. Right one taken from the James Webb Telescope and left one by the Hubble Telescope. We can see clear, rich detail in the picture taken by the Hubble Telescope, but because of the infrared light, The James Webb Telescope revealed orange visible light, which shows the faint heat glow of dense cloud clumps of cosmic dust. Some of them might even be colder than -250 degrees. That's something that astronomers had no idea about from the Hubble Telescope. Only the rich exposure and pixel density of the James Webb Telescope made that possible. Next, take a look here at these two images of the antennae galaxies to see the visible difference and details in the picture on the right, taken by the James Webb Telescope. Again, the James Webb Space Telescope increased the number of pixels greatly, which revealed a lot more details and colors. Now take a look at these two images of the same part of the Taurus molecular cloud, which lies around 450 light years away from Earth. These images were taken especially for its relative closeness, which makes it a great region to study and understand the formation of stars. The image shows how clouds of cosmic dust appears dark and obscuring when observed with the Hubble telescope, but they're seen to glow when observed with an infrared telescope such as the James Webb Telescope, thus revealing richer details. These two pictures are of the Carina Nebula, a region of massive star formation in the southern skies. The picture on the right is taken in infrared light by the James Webb Telescope. When viewed under infrared light, the picture is a lot sharper, and numerous new features can be seen in high detail, unlike the picture on the right taken by the Hubble Telescope. Now, we have a comparison of two images of the Helix Nebula. The left one is a relatively older photo taken by the Hubble Telescope, and the one on the right was taken later using the James Webb Telescope. Due to the infrared vision of the James Webb Telescope, the new image reveals strands of cold nebular gas that are much less prominent in the old picture viewed under visible light from the Hubble Telescope. Also, it's clear that the contrast and exposure is highly improved when the same region is viewed by the James Webb Telescope. Last, but definitely not least, we have a comparison of two images of the Orion molecular cloud, and you can see how the picture on the right, taken by the James Webb Telescope, makes the details a lot more focused and sharper. On the other hand, the picture on the left, taken by the Hubble Telescope, is rather blurry and doesn't properly make the features clear. Well, after comparing these 11 pictures, I think we can safely conclude that the James Webb Telescope definitely made many new discoveries possible for astronomers, thanks to its amazing pixel density and picture quality. Also, in all of these pictures, the James Webb Telescope definitely showed clearer and sharper details because of its use of infrared light. On the other hand, the Hubble Telescope made use of visible light, due to which the image quality and resolution was weaker. So what do you think of the two telescopes and all of these images? Do you think the James Webb Space Telescope is definitely the better choice? Or do you think the Hubble Telescope also deserves due credit for all the discoveries it enabled for astronomy?